So let's analyze kind of the middle of the page. Y'all, I'm going to try to maximize my screen space here. Give me just a moment. All right, cool. So here's what's happening. Here's your plain old geometry, SOHCAHTOA, adjacent, opposite, hypotenuse. We all know that. We are transferring this on a coordinate grid. And the coordinate grid has X values and it has Y values. And remember, you're doing a project over what tomorrow? What is it? What kind of circle? Yes, unit circle has a radius. All circles have a radius. So we're going to analyze these trig ratios based on if there was a circle drawn on the coordinate grid. So with that being said, remember, X can be positive or negative because it's on a coordinate grid. Same with Y. Y can be positive or negative because it's on a coordinate grid. But a radius always has to be positive because radius is a distance. It's the distance from the center to the edge of the circle. So remember, this is always positive. Just the radius. All right, oops. So here's what's happening. I feel like this is going to move, so I'm going to put that there. Okay. So this top row, you pretty much know this top row. Again, this is like algebra. You got your cosine, adjacent over hypotenuse. You got your sine, opposite over hypotenuse. You have your tangent, opposite over adjacent. However, we're dropping it on a coordinate grid. So anytime you see cosine, the X value is always on the top. It is X over the radius. The X value, the X coordinate goes on top. The sine, the radius is still on the bottom, but the sine always goes with a Y value. And then tangent, tangent, you need to highlight this. Take a lid off the highlighter. Tangent is sine divided by cosine. These down here, I'm going to assume you guys have not seen these. These are just reciprocals. This SEC, that stands for secant. The CSC, that stands for cosecant. And then the COT, that stands for cotangent. And they are just reciprocals. That's all they are, y'all. If you notice, that's X over R, that's R over X. And the other one is R over Y. And then cotangent is the reciprocal of tangent. But what makes these a little weird, and y'all will get used to them in like 5 minutes, is they're counterintuitive. The only one that's intuitive is cotangent because it has the word tangent in it. So every time you see cotangent, you know it's the reciprocal of tangent. When you see cosine, its reciprocal always starts with the other letter. That starts with a C, its reciprocal starts with an S. That starts with an S, its reciprocal starts with a C. That's the best way I can give you to remember it. So remember, cosine's reciprocal is secant. Sine's reciprocal is cosecant. So remember that. All right, so those are your reciprocals. Just flip them upside down. Let's go ahead and take a look at the bottom of your page where everything's going to come together. Okay, so for at the bottom of the page, here you go. You have some angles that are dropped on an X and Y axis. By the way, I'm so sorry. I didn't talk about this symbol. That symbol is called beta. I don't know if you guys know that or not. I'm going to assume you have never seen it before. It's a Greek letter. It just means the angle we're talking about. You're going to see that a lot. So the way that these angles are made is we're always starting on the x-axis and we're just rotating about the origin. So this little baby angle, it stops right here in quadrant 1. I know that point. That point is 6, 8. Has a distance of 6 places away, has a distance of 8 units up. This angle was swung all the way around in quadrant 2. It ends right there. I know that this is -5, 12. And then this swings all the way down to quadrant 3. Oh, the order of pairs already given. Same with quadrant 4. It already gave us where it stops. -3, +3. Okay. So we are just going to find these trig ratios. Remember, cosine is always x over r. So cosine is going to be 6 over 10, but we are so simplifying that. You have to simplify everything. So let's write 3 over 5. Sine is your y value, your y coordinate, 8 over 10. That's going to be 4 over 5. And then let's talk about tangent. What did you highlight? What did you highlight? Did you highlight what I asked you to highlight? What is it? Sine divided by cosine. Good. Look. So for tangent, it's going to be sine divided by cosine. I'm going to show this word right here. You don't have to write this if you watch me. Just watch me. You're going to get it. This is sine divided by cosine. Remember, that's how you find tangent. That is so ugly. Remember, when you divide fractions, it's keep, change, flip. You always multiply by the reciprocal. What happens with these 5s? They do. So it's literally the sine value on top and the cosine value on the bottom. Sine over cosine. So tangent is 4 over 3. What is that the reciprocal of? The one that starts with the other letter. What is the reciprocal of? Cosine. Cosine. So we're going to write 5 over 3. Ooh, that starts with the letter C. It's going to be the reciprocal for the one that starts with the other letter, which is what? Sine. What am I going to write? What's that upside down? Just 5 over 4. And then cotangent, we're just going to flip tangent upside down. Let's write 3 over 4. And then, grab your highlighter. We're going to draw big giant plus signs on all the positive ratios, which are all of them. Like this. Draw a big giant plus sign. They're all positive. So, so, so important. All right. Let's see what happens when the angle is made in quadrant 2. So when the angle is made in quadrant 2, this terminal side goes through -5, 12. Cosine is always x over the radius or the hypotenuse, which is 13. Sine is 12 over 13. Now remember what the pattern was for tangent. Does anyone want to guess what tangent is? What did we get over here? How did that work? How did we get 4 over 3? It's 12 over -5. Good. And what's a positive divided by a negative? The whole thing's negative. Good. So let's just write -12 over 5. Great job. Great job. I'm sorry? Yeah, is it not going? I think it's going. It's on pause. No, it's on pause. We're good. All right. Thank you, Christina. All right, let's start flipping this stuff upside down. Secant. What is this going to look like? I can't hear you. Yeah, that is negative. We keep the sign. Very good. Thank you. What about cosecant? Yep. And what's tangent other than Hamza? You guys know this. What's cotangent? -5 over 12. Great job. Oh my gosh. Miss Harrington's making me answer. It's time to draw plus signs. There's only 2 that we get to draw a plus sign now. What are we going to draw plus signs on? Yes, sine. Okay, what else? cosecant, which is sine. It's sine upside down. Cool. Ooh, quadrant 3. Oh. All right, so it's 2 places to the left. So this is a distance of -2. It's 2 places down. Okay, that's where y equals -2. I need this. What's that? Look at the top of your paper. It is. But what's the measure? It's 2√2. Remember, that's a 45, 45, 90. Negative, when you square those on a Pythagorean theorem, you're going to get positive values. Ooh, you better write small on this. Look what happens. What is cosine? It is -2. Look how far over I scooted. I did that on purpose. Over 2√2. Ooh. You got a lot of work to do. You got to cancel out these 2's that don't have a root on them. Let's do that first. This equals -1 over √2. Is that a good answer? Mm-mm. What are you going to do to this? Yeah. Y'all, I just do the best you can. I know that it's a tiny space here. That's going to equal -√2 over what? Yes. Good. Now listen. This, always simplify before you rationalize, because it's going to make these flips a lot easier. Let's just go ahead and do the flip. Which one is the flip for cosine? Which one of these? Secant. Let's go to secant. So secant is going to be the one that's flipped upside down. Y'all, don't use your final answer because you're going to have to rationalize the denominator again if you do that. Use the one that you simplified right before you rationalized. What is that flipped upside down? Yeah, √2 over -1. What does that turn into? Just -√2. Good. Let's write -√2. And let me just say that one more time because I see a lot of kids do a lot of extra work when you don't have to. Please remember, you simplify it before you rationalize, and you use that to write the reciprocal. So easy. All right, let's move on to sine. Y'all, what is sine? It's going to be the same exact thing because the y coordinate is the same thing as the x coordinate. So I'm just going to write -2 over 2. And then what else is just going to be -2? What else can I write? Cosecant. Very good. And you said it right. Good job. Awesome. All right, now let's talk about tangent. What did you highlight? Scroll your eyeballs at the top of the paper. What did you highlight for tangent? What is tangent? Sine over cosine. Y'all. What's the same thing divided by itself? Then that's tangent. Let's write line. What's the reciprocal for that? Just one. Just one. Yes. How do I say? It's time for this. We're going to draw plus signs. There's only 2 of them that are positive. Which ones are positive? The tangents. Tangent and cotangent. Yes, yes, yes. All right. Quadrant 4. My favorite quadrant. Now remember, let's analyze what's going on here. So it goes through point 3, -3, which means this distance is 3. This distance is -3. And they did not give us the radius of a circle, but you know it. What is this distance right here? What? 3√2. And it's positive because it's a radius. It's always positive. Cosine is always x over r. 3 over 3 root 2. What happens to those 3's? Ooh, that's so ugly. We have to fix it. But it's important. We're going to flip that upside down later. Cosine is going to be root 2 over what? Yes. Good. Sine is negative root 3. I'm so sorry. Negative 3 over 3 root 2. That's it. Negative 1 over root 2, which turns into a negative root 2 over 2. Now we're to tangent. Tangent is sine divided by cosine. What's that divided by that? Negative 1 is positive divided by a negative, so let's write negative 1, or negative divided by positive. Here we go with the flips. Secant starts with the letter S, so we're going to flip the one that starts with the letter C. What's secant? Yeah, root 2 over 1, which is just what? Root 2. Cosecant, flip the one that has a S. What does this turn into? Negative root 2. What's cotangent? What kind of one? Yeah, the reciprocal of negative 1 is just negative 1. No, you keep the sign. Reciprocals keep the sign. What's positive? Your secant. And secant is the reciprocal of what? The main one is cosine, yes. All right, watch. We're going to put all this together. In this little space, the best you can, draw a little baby X and Y axis, and in really tiny letters, write this. All students, this is a little mnemonic, take calculus. I don't know if it's true or not, but we're going to use that mnemonic. What that stands for is where all the ratios are positive. Quadrant 1. What did you draw a positive sign on? All of them. So in quadrant 1, all are positive. In quadrant 2, what did you draw a plus sign on? Sine, and it's reciprocal. We're going to focus on the main function, sine. Oh, look. Sine starts with the letter S, just like that. So in quadrant 2, if only sine is positive, it's in quadrant 2. Quadrant 3, what'd you draw a plus sign on? Oh, look. Tangent. What's the other trig ratio that starts with a C? Cosine. So that's just a little trick to help you, because I am going to ask you questions just like 5 through 10. Let's look at 5 through 10. All right, so for 5 through 10, problem 5 says sine is greater than 0, which means sine is positive. I'm just going to write a plus sign there because it's easier for me to visualize that. And cosine is less than 0. Cosine is negative. What quadrant is that in? Quadrant 2. That's the only one where sine is the only one that's positive. So we're going to write, let's write a Roman numeral 2 right here. Number 6, sine is less than 0, so I'm going to draw a negative. And cosine is positive. Which one is that? 4. Good, it is a 4.
It's always positive. All of the areas are positive.
Yes, the only one where all the trig ratios are positive is quadrant 1. In quadrant 2, only sine is positive. In quadrant 3, only tangent's positive. In quadrant 4, only cosine's positive. Same for the reciprocals. So look, where it says cosecant, I don't really focus on the reciprocals. What is cosecant a reciprocal of? So I'm just going to write sine and draw a negative sign because it's less than 0. And secant is the reciprocal of what? So cosine, looks like cosine's also negative. What corner is that in? Very good. Y'all look. What's a negative divided by a negative? Of course it is. That's why tangent's positive, because you're dividing a negative by a negative. So let's write quadrant 3. Cosecant, so sine is going to be positive on this. Cosine is the same as secant. Secant is also positive. Where are they all positive? Quadrant 1, very good. See if you can do the last two, and then I'll try, and then we'll check our answers together. What'd y'all get on 9? 3, because that's where tangent's only positive. Number 10, if cosine is negative and tangent is negative, then sine has to be positive. So 10 is quadrant 2.